Let's talk about the Calvin cycle. This is the phase of photosynthesis where we make a carbohydrate from CO2 gas. The Calvin cycle has 3 stages. In the first stage, we're going to fix the carbons in CO2. And in the second stage, we're going to reduce the product we made in order to produce G3P. In the third stage, we need to regenerate a molecule known as RuBP so we can turn the cycle again. But let's talk about fixation first. Let's talk about what happens when we bring 1 CO2 into the Calvin cycle. The 1 carbon molecule combines with a 5 carbon molecule known as RuBP. With the help of an enzyme known as Rubisco, we make a 6 carbon molecule. But this 6 carbon molecule is unstable. And so it's going to break down into 2 3 carbon molecules known as 3PG. But note that there are 6 total carbons still. These 3PG molecules are going to go on to be reduced in the next phase of the Calvin cycle. Now remember, reduction is, that's right, gain. Think of oil rig. And so in this step, we are going to be gaining electrons. So let's start with our 2 3PG molecules again. Now, reduction is going to happen in 2 phases. In the first phase, we're going to produce 2 BPG molecules, and we're going to expend ATP to do this. But BPG is just an intermediate. It's not the final product. So in the second step of reduction, we're going to generate 2 G3P molecules, which is what we really want to make. And this is going to involve the gain of 2 electrons, which are going to be delivered by NADPH. And so the outcome of reduction is to produce 2 G3P molecules. Remember that this came from 1 CO2. Now, G3P is the precursor to lots of useful molecules that the plant can make, including glucose. But we need a lot of G3P in order to make some things. For example, we need 2 G3Ps just to produce 1 glucose. And we need 5 G3Ps in order to regenerate RuBP so we can start the cycle again. So let's look at some numbers. From 1 CO2, we can make 2 G3P molecules. And that's not enough to produce either RuBP or glucose. From 2 CO2, we can make 4 G3P molecules. But that's still not quite enough. From 3 CO2, we can make 6 G3P. And this will be enough for us to regenerate RuBP, plus have 1 G3P left over to exit. But we need 2 to make glucose. So this whole cycle is going to turn twice with an input of 6 CO2 so that we can produce 12 G3P. And that will be enough for us to regenerate RuBP and produce glucose. So let's look at the summary. From 6 CO2 during fixation, we're going to make 12 3PG molecules. And then during reduction, we're going to produce 12 G3P from those. 10 of those G3Ps will be used to regenerate RuBP during the regeneration step, and 2 of these G3Ps will be able to exit the Calvin cycle to produce 1 glucose molecule. So this is why the equation for photosynthesis involves 6 CO2 plus 6 H2O plus sun to produce C6H12O6, or glucose, and oxygen.